There we go. So plotting graphs, making graphs, right? How to do it. We talked about the different kinds of relationships. There's a linear relationship, which the graph is a straight line, right? I reminded you about y equals mx plus b and how to find slope. Okay. We talked about the units for slope. We talked about the y-intercept, where it crosses the x-axis, so the y-axis when x equals 0. We talked about quadratic relationships and how they're also known as parabolas, and you get them in math class as x squareds. And then we very briefly, talked about inverse relationships, I think, where something goes down when the other thing goes up. And I think the example I gave you was attendance, right? If your absences goes up, your mark goes down. Right? That's an inverse relationship. And then I think that was a long period. I talked for a long time. Then I gave you these questions, right? And I asked you to do numbers 1 and 2. And I hear that they're kind of challenging. So how about I give you the answers to 1 and 2? That'd be great? Okay. Suppose a student during a lab determines that the y-intercept for a graph of reaction distance versus speed is 3.4. What would this mean in real life, and is it possible? So here's a graph that kind of helps us to explain this. I'm just going to put this down a smidge and write better. Okay, so this is as the speed speeds up, right? So like we'll say 0, maybe 20, 40, 60, right? As the speed of the car increases, the reaction distance goes up. Does that make sense? Right? As you're going faster, remember the reaction distance is the distance you go from foot on the gas to foot on the brake, right? So if you're going faster, naturally you're going to go farther. Okay. But the student during the lab determined that the y-intercept was 3.4, which means that when the speed is 0, the reaction distance is 3.4. Does that make sense? Why not, Jason? You're not even moving. If you're not moving, what's the reaction distance going to be? 0. You're not moving. Right? Is this possible? No. What should it be? It should be 0. Or extremely close to 0, right? Exactly. So what does it mean? It means that there's a problem somewhere. There's a problem with the data. I will agree it's a bit of a trick question. But these are the kind of situations you're going to get in a real life lab, real life situation, right? If you get that, then you need to recognize, oh, hang on, that doesn't make sense. We must have done something wrong. I'll give you a common example. What would be I'll lead you to this example. What would be an example of where you're weighing something, but like let's say you're weighing, I don't know, pennies or marbles. Marbles is better because I've got this. Let's say I got a little bottom of a coffee cup, and I put on one of those balances up there by the clock. And I'm going to weigh marbles out. And I put one marble in, and I get a value. Then I put another marble in, and I get a value. And I keep doing this. What's the graph going to look like? Is it going to be straight, Vinny? Curve? It should be straight divided what? Marbles are all the same size, and actually that was a little bit big. But what happens what if you get like a value of like 1.3 or something when you're doing this? What if 0 marbles weighs 1.3? How come? Because we're measuring the cup. So that would be an example of where you would go, whoa, 0 marbles should be 0. You would have to actually zero this out, right, or subtract it. That's the kind of thing I'm talking about. Okay, does that make sense now? Yeah. In the braking example, at what speed is the reaction distance set? All you have to do here is read the graph. In the braking example, at what speed is the reaction distance 10? Well, the reaction distance, now this should be labeled. This isn't labeled. Reaction distance. When is it 10? So you have to actually read that, go across. At what speed is it? About 14 meters per second. That's all you got to do. Can you do that? I think so. You should be able to do that. Now, I have a sneaky suspicion that the reason you find the first one, it's kind of a weird question. It's not like you're used to. It's kind of a trick. I get that. That second question you should be able to get. But I also get the feeling that people are afraid to make mistakes. Afraid to be wrong. That's okay to be wrong. I'm wrong daily. That's my life. Little joke there. Okay? It's okay to be wrong. Okay? It's okay to be wrong and make a mistake. That's how you learn. Okay, so now, can you do 3 and 4? Are you feeling a little bit more confident about 3 and 4? How would I give you 4 minutes for those 2 questions I'm going to get in? Okay? Even if all you do is, think about it and kind of formulate an answer in your head, that's fine. But try those. I'm going to do attendance. 3 and 4. Number 3, a graph of reaction distance versus speed, and the slope is found to be 0.74 seconds. So we've got this graph. It's reaction distance versus speed. I guess it's the same as this kind of thing, right? And the graph, the slope is 0.74 seconds. Suppose another experiment is made and the slope is found to be steeper. What does that mean? Well, first of all, a steeper slope, steeper line, would have a bigger slope value or a smaller slope value? Bigger, right? Like if this blue one is 0.74, let me put this in blue. Let me get rid of some of this stuff here to make it a little bit easier to read. Right? Okay, so if this one here in blue is 0.74 and the red one is steeper, what might be a possible slope value for it? 9.6? Right. And let's say I'll do another one in black down here that's flatter. What might be a possible slope value for it? Okay, 0.38, right? Okay, so that's good. But what does it mean sort of like in English? If it's 0.96, what does that tell you about this person's reaction time? Slower, right? So in fact here, this is kind of counterintuitive a little bit, the steeper the line, the slower their reaction time is, right? Maybe they're not paying that close attention. Maybe they're had a few drinks, or they're playing with their phone or something, or they're sleepy, right? It would mean a slower reaction time. Did you guys do the ruler drop thing in grade 10 where you measured your reaction time? Do you remember what your reaction time was? Some of you were probably pretty loud. Yeah. Although if you're really paying close attention, you can do it pretty quick, right?
No,
Yeah.
if I pay attention, then I know.
Oh, is that right? Should we try it right now, Anna?
No.
Let's try it with Anna right now, just for fun. Because I haven't really picked on Anna yet, so. And I know she went to bed early last night, so she's well rested. Okay, so just hold your fingers out here. You guys ever doing this?
Yeah.
In grade 10? And the thing is, you're not, like, yeah, right? And so, like, you're not allowed to, like, warm. I'm not going to say, like, 3, 2, 1. Okay? Like, I'm just going to all of a sudden just drop it at any time. Not bad. 35. So then you got to do, like, some kind of formula answer of your answer. That's actually pretty good.
Really?
Yes, I've had kids not able to catch a, that's how bad they are.
Yeah.
So that was actually pretty good.
Thanks.
Were you practicing?
Yeah.
Okay, now number 4 is the hardest one of the bunch. Figure 6, this one right here, shows the relationship between the circumference and the diameter of a circle. So, terminology. What does circumference of a circle mean, Mallory? Oh, Frank. Uh-oh. Lane, what is circumference? Are you Frank?
Yeah.
I'm sure circumference must be close to the same. What is it?
0.
The distance around, circumference, right? And what's diameter? Like across the middle. Okay. So we've got, as the diameter of a circle goes up, as the distance across the middle goes up, the circumference also goes up. Okay, so the question is, would a different circle circumference create a different graph? If you had a different circle, would you get a different graph? Megan, what do you say? You say yes. Okay. If you have a different circle, we got one yes. If you have a different circle, we get a different graph. Jason? Yes? Me? Yeah, different size circle. Different graph. Okay. Alright? You're kind of giving me the no. So, you different graph? Other Mallory. What do you say? Come on, be brave. Okay. the same graph? You can have different numbers, but it would be the same, like, exactly the same?
No.
No, it has to be the same, wouldn't it? Or it has to be different. Different numbers. Alana, right? What do you think? Yes, you have a different graph? I think we got a little bit of crowd mentality going on here. You think so? Am I known for that?
Oh, it's not pretty different.
How many circles are on that graph? No, at least 5. Really? Because I see circles that have a diameter of 1, and another circle with a diameter of 2, and another circle with a diameter of 3, and 4, and 5. In fact, because they're joined together, you could argue there is an infinite number of circles having diameters between 1 and 5. That is not one circle, that is at least 5 circles. Different circles would give you exactly the same graph. Yes, I know it's a trick. But you gotta think. That's what critical thinking. Would a different circle circumference create a different graph? The answer is a resounding no way. In fact, if I gave you a circle with a diameter of 6, can I squeeze it in here? If I gave it to you of 6, where would it be? Be right along that graph, be right there. You could predict, could you not? Absolutely. What are the units of slope? Okay, now how do we do this? What are the units for the slope? You take the y, because slope is y, divide by x, the rise over the run. You're going to take the slope of the y, and you're going to divide by the slope, or sorry, the units of the y, and divide by the units of the x. So it's, in fact, it's going to be what? Centimeters over? Oh. Centimeters over can you cancel those? Well, but then you get nothing. You get no units at all. Is that possible? Can you get no units? Why not? We just did. Centimeters and centimeters. Do you not measure circumference of circles in centimeters? Can. Do you not measure diameters of circles in centimeters? You can. When you take the slope, centimeter, 5 centimeter, is in fact no units at all. Yes, that is entirely possible. Am I blowing your mind? That's entirely possible. What is the value of the slope? Now, what do I mean here? When I say value, what is the value of the slope? I want a number. Now, I think I showed you kinda how to find slope, but we probably should review, right? Does it matter which 2 points I pick for slope? No. Students tend to like to do what? They like to pick the outside ones because that's how they were first shown. But the fact is, it doesn't matter. So I'm going to, just because I'm a jerk, I'm going to pick the first one and the fourth one. But it doesn't matter. And even after I say it doesn't matter, there's still going to be some of you later that are going to say, Mr. Bennett, does it matter which points I pick? And I'm going to give you a frowning. Because I'm saying right now, it doesn't matter. How do you find slope? You take the change in the y, divide by the x. So we have to sort of estimate here, don't we? What's this y value right here? What do you want to say? What do you want to guess?
13.
13? Is it right in the middle?
Close.
It looks pretty close. How about we go 12 and a half? I'm picking 12 and a half. What's this y value right here? I'm going to say 6. That's the difference. That's my y2 minus y1, right? That's my difference in my slope. So 12 and a half minus 6 is going to be 6.5. And now my x is here is going to be, this is going to be x2 minus x1, and I need to do the calibration thing here. That's going to be 4 minus 2, right? Which is 2. And 6.5 divided by 2 is 3.25. 3.25 what? No, there is no units for the slope, remember? We established that back in B. Just 3.25. A lot of things do have a unit, but some don't. Okay, so that's the value of the slope. 3.25. Now, D is the big daddy question of the day. What is the meaning of the slope? What does the slope mean? What does the slope tell us? Because up here the slope was 0.74. The slope told us the reaction time. Measured in seconds, Jason. The reaction time. It's okay to be wrong, Jason. You're learning, man. Yeah, don't worry about it. Okay, so who wants to be brave? Excuse me. And tell me what they think, what's the meaning of the slope here? What value does it have here? And you do know this, it's just kind of weird. The meaning. What is the meaning of the slope here? It's not reaction time. It does, Vinny. That's pretty good. You're on the right track. There's a word for that. What is the word for the relationship between circumference and diameter of a circle? It's on the tip of your tongue. You just don't realize it. It has a special name. And it would be the same in French, too, by the way. I'll tell you, very rarely does a class actually get it. But once I show you, you'll go, oh, yeah, of course, right? What's the formula for circumference of a circle? Like the algebraic formula. C equals? No. Well, that's area pi r squared. Is that what you're thinking?
Yeah.
What is the formula for circumference of a circle? Is it not pi times d? Right? You guys know that, right?
Yeah.
Okay, now, what is the value of the y here? It is circumference. That's the y. And what is the x? Diameter. So c over d is the slope. Can I rearrange this so it says c over d? How do I do that? And what is c over d, my friends? That's what the word was on the tip of Vinny's tongue. He just didn't realize it. You said it's the relationship between circumference and diameter. What's that special word? Pi. In fact, it was the Egyptians, the guys that built the pyramids, that came up with that. They used 22/7, I believe. What's the value for pi that you all know? 3.1415926, and I don't know what after that. 5? Maybe, I don't know. What was the slope value that we came up with? Is that pretty close? It's pretty darn close. Are you going to get perfect numbers? No. And then remember, where did we come up with these? We just saw a graph and we actually picked the numbers. If I actually gave you circles and had you measure, would you get closer to the value of pi? So here we have an example where the slope has a meaning of pi, but it has no units. Right? Does the slope often have no units? No, in fact, it's rare. That's why I chose one. I also use this one because you guys know what pi is, right? Is this all very confusing? It's okay. I've always had to explain this to kids. I don't expect this to be one of those reviews where you go, oh yeah, I know that, right? Okay. This is going to be some challenge here. Okay? Because this is going to be a challenge for somebody, so you got to be introduced to it early. All right, so there are now 1, 2, 3 exercises, and we will treat these very much like the ones we did in the review. Normally what I do is I say, okay, let's do 1, 2, and 3, and then everyone struggles. I say, okay, well, how about I do the answer for 1 and then go back? Well, how about we just try number 1? I'll give you about 5 minutes, tell you the answers, get your confidence up, and then I'll move you into 2 and 3. So go ahead and try number 1. Okay? You are only calculating, you're just reading the graph and you're talking about the slope. They get progressively harder. So take a few minutes, try those. It's okay. Would you agree that A and B were pretty easy, and then after that it starts getting pretty hard? All right, fair enough. The graph shows the mass of 3 substances for volumes between 0 and 60 cubic centimeters. What is the mass of 30 cubic centimeters of each substance? So you're looking for the mass, that's the Y, of 30 cubic centimeters. So you got to find 30. That's 20. 30 would be right there. Right? So that would be like, that one there would be like, well, these go up by 20, I think, right? So that'd be like 22, something like that. 25, something around that, 22, 25, somewhere in there. Then you got 50. Oh, yeah, right. Okay, each one's 20, right? 20, 40. They go by 25. Oh, okay. So 50. Even a little bit more than 50 probably, right? Okay, 55. See, it's okay to make mistakes. you think I did that on purpose? No, I didn't. I'm not that smart. This one here would be, looks like it's just under 100. We'll say 95. All this is can you read a graph? Currently, I struggle. That one there, we're going to say 150? Okay, good. If you had 100 grams of each substance, what would their volumes be? So now you're reading this 100 and you're going across. So that one there would be 20. That one there would be 36. Okay. And then way over here, 60? It's like 50. Okay, so those are relatively easy, especially if I had a bigger graph and I was not quite as blind as I am. What are the units of the slope of the graph? I showed you how to do this. You take the units of the y and you divide by the units of the x. And so the units are going to be grams per cubic centimeter. Grams divided by cubic centimeters. Grams per cubic centimeter. Does that sound like something you've dealt with before?
Yeah.
That's good. I think you should have. What is the value of the steepest slope? So the steepest slope is the top one, right? This one is the most steep. Again, does it matter which 2 points you pick? Does not. How many people pick the outside ones? Probably lots of you. Some people like to pick the outside ones because now, here's where you got to be careful. If you pick the first one here and it's 0, that works out good, right? Because when you subtract, like if I'm going to subtract 300 minus 0, well, you should be able to do that in your head, right? But it's not always going to work out like that. Like this is going to be like 300 divided by 60, right? And you can do that, that's fine. But be aware, if it doesn't go through 0, 0, it's not going to work. What's 300 divided by 60? I think it's 50, right? Am I going to get 50 if I pick a different 2 points? I sure should. Let's pick those ones there and that one there. So this y value here is 250. 250 minus this one here is 100, which is 150.
Divided by 60 is not 50. It's 5.
5, right. Is that what I said?
You said 50.
5. I meant 5. Again, it's okay to make mistakes. I'm just modeling how to make a mistake and be okay with it. This x here is 50. Oh my goodness. 50 minus this x here is 20. That's going to be 30. 150 divided by 30 is how much? 5 what? Grams per cubic centimeter. 5. We just found the points there, Anna. I know, I got bad writing.
Yeah.
I learned how to write in Australia, so everything was upside down.
Okay.
I should also say that when I was in Australia, I went to Australia halfway through grade 1. They put me in grade 2. They tested me and they said he should be in grade 2. That's how smart I am. But then when I came back after that whole year of grade 2, all my friends back in Canada were in grade 2. So I took like 4 months of grade 1, 10 months of grade 2, and then they come back and do 6 more months of grade 2. I'm a little weak on my grade 1 stuff. We went to Australia for the year. That's where the magpie took a big chunk out of my head. Should you get the same slope, 5, as if you took those outside points? Yeah, why? Because the line is straight. It doesn't matter what points you pick. The line is straight. And it's 5 grams per cubic centimeter, which means that every cubic centimeter that you add on, the weight goes up, the mass goes up by? How much? 5. That's what it means. 5 grams per cubic centimeter. Every cubic centimeter, there's an increase of 5. Okay, part E. I kind of led you along here. You might not have got it before, but you might know it now. Wayne, what's the meaning of the slope? It's not pi. And it's not reaction time. Something different. You do know it, you just don't realize it. What are the units? Wait, what are the units here? What do we got? Grams per cubic centimeter. What do you measure in grams per cubic centimeter? You know? Jacob, do you know? It's related to mass and volume, but what do you measure that's related to mass and volume in grams per cubic centimeter? Trent, do you know? I don't remember what year you learned this in what science. I don't remember. It starts with a D. D, you got it? No? If I start writing, will that help? What is the meaning of the slope? What do you measure in grams per cubic centimeter? Some classes get it. It's called the density. How many people had an inkling that's what it was, but they were afraid to answer that? Some of you, I know for sure. It's the density. What is density? Give me an example of something that's really dense and don't say you. Gold is really dense. It's very heavy even though you've got a small amount. Give me an example of something that's not very dense. Air, cotton candy, styrofoam. Right? Density is how heavy it is for the amount of stuff. These are three different densities. You measure density in grams per cubic centimeter. So there's a third example of how the slope actually means something. We had reaction time, we had hot, this time it means. How did we come up with that? Well, what's the formula for density? Does anyone remember? I don't really wish I knew which year you learned this. What is the formula for density? It's not. I think it is. It's mass over volume. What's the Y quantity here? Mass. What's the X quantity? Volume. When you take the Y divided by the X, mass divided by volume, you get density. And it's measured in grams per cubic centimeter. So there's all these different clues that help you figure out what it is. It's density. Okay. Question number 2 says, during an experiment, a student measured a mass of 10 cubic centimeters of ethanol and so on, blah, blah, blah. Now, you actually have to graph it. Notice again, it's volume and mass. When you have a table of values like that, Alana, which one usually is the X and which one is usually the Y? Yeah, that's true, but when you've got it like in columns like this, when you've got a table of like which one of these is the X is what I'm saying. The first one is usually the X, right? 99.9% of the time that's the X and that's the Y. Okay, so I want you to plot those. Draw a line that fits all points. Again, do not connect the dots. You're going to black thread it. You're going to eyeball it. You're going to create a trend line. And it's quickly erasing. Find the units of the slope. Find the name given to this quantity, or what's the meaning of it. What's the value of the slope. Oh, and then D and E are going to cause some grief. Go ahead. That you've given it your best shot. Okay, so plot the values given in the table and draw the curve or line that best fits the points. Describe the resulting curve. Is it a line or is it a curve? So when you plot them, I believe these just go up by 10, right? So we got 10, 20, 30, 40, and 50, right? Okay, and then up the side here, we're going to go up by, does it go up by 5?
Yeah.
I think so, right? 5, 10, 15. It's always good to make your graph as big as possible. Okay, so 10 and 11 is going to be like about there. Hang on, I got to do this. 20 and 18.9 is going to be like about there. 30 and 26.8, 30, 20, say roughly there. 40 and 34.7 is almost right there, and 50 to 42.7, so like about there. It's a pretty much straight line. And then you're supposed to draw the resulting curve. So then you're supposed to actually get a ruler. I say, then you're supposed to get a ruler. There it is. Okay, and then you're actually supposed to put it on there. Now, with a real ruler, it's a little easier. Thanks for your confidence. Okay, does that represent the data pretty good?
Yeah.
Pretty close, right? That's called the black thread or the eyeball method. That's okay. You are, because are those data, are they perfect? Oh, you know what? We should talk about this right now. I got time. My point here is that everyone going to have exactly the same line? No. Is everyone going to get the same slope value? No, because you might pick data points, different data points. Whoa, Mr. Bennett, you told me it didn't matter which data points you picked, right? It does matter when you're doing real ones like this. Give me a second there, Mr. Goodine.
It's okay, no, I don't.
Okay. So like, for example, is this data point right on the ruler? This one right here? It's a little bit off, right? Should I use that one? No. I should use ones that are right on the line. They represent, they're sort of like the representative for that data. Jason. Say again? You can do that. What I'm saying is when you're picking the data points, when you're picking which ones to find the slope, you should pick ones that are on the line that you're selecting. If, like I said, for this one here, that one's a little bit off, that one's a little bit off. Don't use those. Pick ones that are as close to the line as possible, that are the best representative. Okay? So you will get slightly different ones. All right. So what is the value of the slope of the line? That's good. So I'm picking those two that I picked in red. This y value here was 42.7. And this y value here was 18.9. And now I'm going to pick the x values. This x value here is 50, and this x value here is 20. Okay, now I need to calculate. Thank you. $42.7 minus 18.9, and we're going to divide that by 50 minus 20. I think I can do it in my head. Did you get about 119 over 150?
No.
Oh, there's one get across.
0.793 repeating. Ooh. Remind me someday to talk about repeating numbers. That's a great little rant. 0.79. Didn't you get that, Jen? 0.79? Are you happy that you got the same number as me? How happy would you be if you got 0.8 and I got 0.79? You'd be still pretty happy? Okay. How close do you have to be then, do you think? Still working with that earbud there, right? Trying to hide it now. 26 years of experience, man. I've seen a lot of tricks. Nothing new. I've even seen the guys, they'll have the long hair and they'll stick, or the girl will pull the hair over to one side and stick the earbud in on one side. See that? I can't do that anymore. 0.79. Now, Jason and I had a little discussion about the y-intercept. When I take this ruler and I go back on here, did yours automatically go through the 0, 0 point? It shouldn't. In fact, it goes through right there, doesn't it? What is the approximate value of the y-intercept? It's like about what? About 4? We'll say 4. So when we write our equation, when you go y equals mx plus b, have you guys done this? Y equals mx plus b before? I think you have. What's the slope? 0.79 x plus b plus 4. That's the equation that relates this. That's the equation that works for the data. Why do scientists, why do they care about the equation? Why do they have to do that? It's not just because they like nuts. What good is it, I guess, is what I'm saying. Well, it's so that they can come up with a relationship. They can figure out that what another value. They can make a model. They can predict. Like when they're predicting Hurricane Irma down there in Florida, they have equations. They can model it. They can tell you where it's going to go. This is obviously not as complicated. Okay, now I know that I've hinted at the answer to E. Why isn't the y-intercept equal to 0? Let's just read the question. We never actually did that. During an experiment, a student measured the mass of 10 centimeters of ethanol by pouring it into a graduated cylinder. Do you know what a graduated cylinder is?
Yes.
It's already finished high school. Thank you. Thank you very much. Right, it's one of those things that you measure with, it's got the marking that's graduated is what it is, right? So they're measuring it. They're measuring it. Okay, so how come if I've got 0 volume of ethanol, if I have 0, how come the mass is 4? Because the graduated cylinder has a mass of 4. Just like my paper cup with the marbles. The graduated cylinder is equal to 4 grams. Does that make sense, Mallory? I've thrown a lot of information at you. Most of it is kind of review. But I agree, it's challenging review, right? I cherry-picked the toughest parts. Why am I doing all this? Because we're going to do a lab where you got to graph, and I need to know that kids can graph and figure stuff out. Okay, so it's important. 11:10, I got 8 minutes. I am going to go through the answers to that tomorrow. If you choose to use the next 7 minutes to do that, that's awesome. If you choose to pack up and do it at home, also awesome. If you choose to pack up and say I'm going to do it at home and then leave your binder in your locker, not so awesome. I will do that question for you. Okay, and then we're going to do some graphing on computers because it is 2017 after all.